Mike Hilligard, our registered professional forester, to introduce our topic.
All right. If you've ever been to Reno, you'll notice that over on this side we have dry and desolate and dusty area, and on this side we have lush, green, wonderful trees and mountains and forests. This is mostly due to something called the orographic effect.
Hi, I'm Caroline Rock, a meteorologist, and I'm going to define the orographic effect. The orographic effect is the term used to describe changes to airflow when the topography of the land forces air upward. These changes can cause disturbances in the weather system. And with us today is Mallory Pappas, our expert hydrologist, to discuss the orographic lift.
Hello! Alright, so orographic lift occurs when an air mass moves from a lower elevation to a higher elevation over rising terrain. As the air mass gains altitude, it cools down adiabatically, which can raise the relative humidity to 100% and create orographic clouds, which serve as a source of precipitation, as shown by our cloud Mike.
Now I'm sure you're wondering what adiabatic means. Adiabatic basically means that there is no heat gained or lost by the system. Now we're looking at two things in regards to this when we're talking about the orographic effect, and that is the dry lapse rate and the moist lapse rate.
According to the National Oceanic and Atmospheric Administration, the dry lapse rate is a rate at which the temperature of a parcel of dry air decreases as the parcel is lifted in the atmosphere. The dry adiabatic lapse rate is 5.5 degrees Fahrenheit per 1,000 feet or 9.8 degrees Celsius per kilometer. Moist rate. NOAA defines this rate as the rate at which the temperature of a parcel of saturated air decreases as the parcel is lifted in the atmosphere. This rate is not constant like the dry lapse rate, but is dependent on the parcel temperature and pressure.
Another important effect are the windward and leeward winds. Windward winds travel up the side of the mountain, bringing moist air up the mountainside. On the leeward side, winds are dry as they descend the mountains. Winds are very important as they are the driving function of the orographic process. Temperature is another key component of the orographic effect. As the winds on the windward side of the Sierras push the air mass up the slope, they cool and begin to condense. As the air mass is pushed down the eastern slope, it then warms and expands again.
As Cloud Mike begins his ascent up the mountain, moisture begins to condense until enough moisture has accumulated for precipitation. An example of this can be seen in the Sierras, which receive up to 80 inches of rainfall a year, while the slopes of the eastern side can receive less than 10. Take a look at this satellite image. You can see the visible difference.
The lack of precipitation and expanding warm air create what is known as a rain shadow, the visibly drier eastern side of the Sierras. In a sense, the mountains block the passage of rain-producing weather system and cast a shadow of dryness behind them. This produces very different environments for different species to thrive. For example, there are more pine and fir on the western side of the Sierras, while there's more juniper and brush on the east side.
Hope y'all had a fantastic time learning about the orographic effect, and that you never have to move to Nevada.
Yeah.